Hi, my name is Spandan. India is one of the most developing countries in the world. Development of a country depends upon its natural resources, economics, education and transportation. But the last two factors depend upon the country's space missions. But do you know what? For each and every space mission, it emits almost 50 to 60 tons of carbon dioxide gas, which causes greenhouse effect, global warming and ozone layer depletion. And also, it needs 15 to 16 years to overcome this pollution. So, because of all these problems, shall we stop our space missions? The answer must be no. Our progress must not stop because of these problems. Nowadays, space companies are using a lot of fuel for reaching and completing the task quickly, which creates a lot of pollution and is also very expensive. So to overcome these problems, I have made my model, Ghoomar, the spin and jerk launcher. American company Spin Launch is trying to use this technique for satellite launching since last 3 to 4 years. But they are failing due to use of only spin technology and remote sensing. Because of use of the spin technology, whenever they release the capsule, it falls into the chamber itself and gets damaged. When I was thinking for a solution to this problem, I saw a video of a farmer using a sling to protect his farm from birds. That's when I realized that instead of using it horizontally, if I use it vertically, I can use it for sending satellites into the atmosphere. And that's how I created my model. For the construction, I first took a circular metal box and attached a launching passage to it. At the center of the metal box, I pivoted an axle which had a capsule holder on one of its ends. To rotate the axle, I connected it to the motor which was powered by a 12-watt battery. To create vacuum-like circumstances, I attached an acrylic sheet to it. To give jerk to the capsule, I attached a stopper to it. And lastly, put all the equipments on a metal frame. Capsule, which is basically a fairing structure that contains a two-stage rocket and a payload of 200 to 400 kg mass that could be a satellite, lander, rover or orbiter as per the needs. The principles used here are spin and jerk. Because of centrifugal mass acceleration technique, when the axle starts rotating and achieves a particular speed, mass of the capsule becomes zero, so like in a sling, and when we apply stopper, we give jerk to the capsule and it is launched into the air. Its advantages are: first, it's reusable. Second, it's cost effective. Third, it uses less fuel for satellite launching. Fourth, in less time, melee launchings are possible. Because of use of spin and jerk technologies, accurate launchings are possible. And sixth, it's eco-friendly. For the launching, we first insert the capsule in its holder by removing the acrylic sheet and then again attaching it. By turning on the motor, we give circular motion to the capsule and the axle. And lastly, by applying stopper, we give jerk to the capsule and it is launched into the air. Future improvements. First, use of carbon fiber reinforced plastic. Second, use of electromagnetic stopper. Third, use of solar energy. Fourth, manufacturing of lightweight satellites. Fifth, use of aerodynamic capsule fairings that could bear high temperature and can be collected back by using parachutes. For the real-time mathematical analysis, in real time for building this model, we will be using the material carbon fiber reinforced plastic, which is a composite material and also has a very high tensile strength, that is 3500 megapascal to 7000 megapascal, so there would be no back pressure on the mechanism. A radius of 45 meter is required. RPM of the axle must be 450 RPM. Vacuum is also required to minimize the atmospheric drag acting on the mechanism, and also the electrical energy used to operate the mechanism. To create a complete vacuum, it requires a lot of energy and is also very expensive, so a partial vacuum is also okay. Each launching needs nearly 60 to 70 megawatt power. When we apply the stopper, the capsule will go up to an altitude of 70 to 80 kilometers without any ignition, without any pollution and also without damaging the ozone layer. And when the capsule has reached this height, we can use the thrusters present in the rocket for the further journey. All within a 321 crore to 325 crore if we need to construct this model in real life, and as this is a one-time investment, once we construct this model for each and every launching, we will need only 1 to 2 lakhs of electrical current and the maintenance. The costing is only half of the entire Chandrayaan 3 mission. So, by my model, I am fulfilling this year's science exhibition theme, that is Science and Technology for Sustainable Future, and the sub-theme Transport and Communication. And I can also say that my model is setting a pug mark for India's space missions in future. Thank you.